Okay, and the recording started. So, hi Anuj, hi Alan. So, we are doing a quick run through of the balenaSense project for the hackathon participants. So, as you know, we are having a community hackathon this weekend, and a lot of participants has shown interest in sensor interfacing, taking the values and checking it on a dashboard. And we have a pretty interesting project around that called balenaSense, right? So this would make a lot of sense to have this demo for the participants, and Anuj and Alan will be walking us through what is balenaSense, how you can interface sensors on the RPi or fin or similar board which is supported in balena, and basically how you can read the data coming from the sensors, I2C sensors in this case, in a containerized environment, and check that on the web. So let's start with a very small introduction about what we do at Balena, so everyone has an idea, and hopefully, the participant will be able to also see you in the during the hackathon, walking around, helping each other with the ideas and helping them make the project. So I'll go first. I am Ayan. I am in India. I'm a developer advocate at Balena. Uh, yeah, so that's my job. Anuj, what about you?
Yeah, so hi guys, I'm Anuj. I work as a hardware engineer at Balena, so I work on projects like Balena Fin.
Awesome. And we have Alan.
Hey everyone, I'm Alan, and I'm a hardware hacker in residence here at Balena. So I'm making a lot of projects that utilize the platform.
Yeah, that means Alan gets to work on a lot of interesting projects that you see on Balena Hub, on Balena Playground, and one of them being the Balena Sense project, which we're going to be talking about today. So, Alan, why don't you tell us about what is the project all about, and why we have made it in the first place?
Sure, sure. balenaSense is essentially just a great starter project for using the Pi 3 and using the Balena platform. And it allows you to connect a variety of sensors to the Pi and then view the data coming out of those sensors on a Grafana dashboard. And so you're getting the history of the data coming from the sensor. And then you're also able to understand the fleet aspect as well, because you could place multiple ones of these around and you could compare them, and you can look at the data from multiple sensors, or you could connect multiple sensors to the same Pi with the latest version of balenaSense.
Right. So, as I understand, we used to have this Balena Sensor V1 project that we use the Raspberry Pi Shield, which Anuj has, which we used to do, but now we converted that into something called the Sense Block. So, what's the really difference between these two approaches?
Sure. The main difference with version 1 of balenaSense was that it had separate drivers for each type of sensor. So it only supported a few sensors, including the Sense Hat, but it had these proprietary drivers as well. One of the big things in version 1 was the air quality, that we were measuring this, supposed air quality, especially from the BME 680 sensor that provides a VOC kind of a gas reading. And what we found was that that was not really providing accurate air quality. Like you really need more sensors and you need to spend a little more money to get air quality. So we kind of pivoted balenaSense in version 2 to be just a pure sensor reading project. So it supports a wider variety of sensors, although not the Sense Hat, but it does support more sensors, and you can connect multiple sensors at one time, which you could not do on the earlier version. You don't get the air quality, but you still do get the gas content. If you're using a BME 680, you can still see the gas reading, but then it's up to you to kind of use that however you'd like. And that's kind of how balenaSense is now overall. It supports a variety of sensors, not just temperature, pressure, and humidity. You can connect some UV sensors. So it really just outputs, stores, and measures the data that it's getting from a variety of sensors now.
That
Yeah,
sounds pretty fascinating.
I think the advantage is that you don't have to add drivers for a sensor every time now.
Mhm.
Like now, because you're using some standard like the IIO. It's
Yeah.
easier to add support.
Right, right. We're using another item is that we're using blocks. As Ian mentioned, blocks are pre-built pieces of functionality, and one of those blocks is the sensor block, and that has many drivers in it for many of the different popular sensors that you can use with balenaSense. So, there's some trade-offs between one and two, but we feel that two is a much better platform to build on. We can always add more to it. PRs are always welcome, but it's a good base and it supports a wide variety of sensors, and that's why we say it's a great beginner project. As we'll go through, if you just have a Pi, it can be practically any Pi or fin. It doesn't support the 0, but anything above that should be fine.
That's great. And so one thing is that you mentioned this sensor. This is an I2C based sensor, so you can have a lot of them daisy chain on the same bus and still feeding value. And yeah, that is pretty interesting. Uh, One thing which I think is would be a very common question is so how do we actually obtain the sensor interfacing in a containerized environment? Because Balena is built on microservices, right? On top of Balena OS, we run different containers on the legacy Raspberry Pi running Raspberry, and we can just interface, we can enable the I2C bus and get the reading. So, what are the different config that we need to do in this case?
In this case, the block that we pre-built that interfaces with the sensor basically does all the work for you. It manages to pull the data from the I2C bus from the host. So there's really no like configuration other than just the steps we'll go through to push the fleet. Sorry, I just froze there for a second. Um, so yeah, there's no special configuration. We're using I2C sensors that are supported. As long as the sensors on the bus do not have conflicting addresses, you can add as many supported sensors as you like. And in our repository, which we can look at, we have a list of the supported sensors. It's quite a variety, um, but it is only I2C and only the ones on the list. So you can't just necessarily get any I2C sensor you can find. They still have to be on our supported sensor list, but it is a larger list than it was in the first version of balenaSense.
Wow, that's good. So, Balena blocks is basically the boilerplate which gives you everything. You just need to include that in your project and connect the sensor, and you are basically good to go. Yeah.
Yeah, the Docker compose file, which is like a list of the containers that we're using, that shows or that has all of the basically blocks that we need. Some of the blocks are not necessarily our blocks, but for instance, the database we're using is Influx. They publish an image, and we're just using the image as is. So there's really very little like proprietary code for balenaSense version 2. The sensor block that we're using outputs all of the sensors that it finds. It takes all of the data from all the sensors it finds and just outputs it as JSON data. So basically, these blocks just kind of fit together. We have a block called connector that we created that looks for JSON data on certain ports. And if it finds it, it puts it into Influx database just as is. And then we have the dashboard block, which looks for an Influx database. And if it finds it, it creates a default dashboard for it. So all of these default pieces are finding each other, and you really have very little configuration. And it's a great template for projects that people may want to build on their own. Just look at how we've put these blocks together, and you could think of plenty of other applications for these blocks and ways that you could connect other blocks together and make your own projects.
That is very interesting. So to simplify it, we are saying that we are having different sensors on the I2C bus, and the connector block which Balena has, it takes all the data from all these I2C based sensors and convert them into a JSON, which is read by the which is stored in the Influx DB and plotted on the Grafana dashboard. Yeah.
Yeah, that is accurate. The only difference I would say is that the sensor block is generating the JSON from the I2C devices, and then the connector block is finding the JSON. But yeah,
Right.
that's exactly how it's put together.
And it's good that you mentioned that people can think of different applications using these blocks for different purposes. Like instead of having the sensor block, they can have a block that measure the internet speed and log it to the dashboard. So that really makes sense, and I'm looking forward for the hackathon participants to reuse this block for all kind of projects. But I'm really very excited to get the hands dirty. So Alan, whenever you are ready, just let's start with the assembly and everything.
Sure. Yeah, the assembly is pretty straightforward. You need a supported version of the Pi, and as I mentioned, really anything above a Pi 0 should be fine. Excuse me. And the application will automatically know which version of the Pi you're using, so you shouldn't have to really specify anything. But we'll get to that part. You'll need an SD card. I would say at least 16 gigabytes. You might be able to get by with 8. This is not a very resource-intensive project. Of course, a power supply. Oops, let me get that in there. So you'll need to power the Pi. And then as far as the sensors, I think, Ian, you had posted a list of the supported sensors, and that is on the GitHub repo for balenaSense. We also have a blog on the blog section of our website about balenaSense. So if you look for that, you'll be able to see the list as well. And basically, I think it's about 12 or 13 different sensors, and the most popular ones are what these are the. Let's see if I can get that in focus here. There we go. Yeah, sorry, the lighting is a little off today, but this is the BMP 280. There's also the BME 680 and the BME 280. These are all popular sensors that work with balenaSense. And as I mentioned, there's also other sensors like UV sensors. I think there's some A to D converters. There's a number of different things that that you can use other than temperature, pressure, and humidity, but those are the most popular. And as far as connecting the sensors, this is the only area where you really have a little bit of like setup and construction that you need to do. If you look at this, most of the sensors that you get today, many of them have this connector on the end. Oops, this little
Yeah.
piece right here. It's called a quick connector. It's SparkFun's prototyping I2C type connector. And it's basically a 4-conductor connector that allows you to easily connect sensors together or connect a sensor to a device. And so if you look at this wire here, this is a daisy chaining type wire. So you could connect 2 of these together. So I'm just going to take, oops, let's see if I can get it on the camera. I'm going to take 2 of these sensors. Oops. And I'm just going to connect them together. But you can certainly just use one sensor. That's the minimum needed. But as long as these sensors do not conflict as far as their I2C addresses, and when I say I2C address, what I am referring to is the fact that every I2C sensor that's connected to the I2C bus on the computer is has its own unique address, and that's how which device you're getting the data from. I'm just having a little trouble. You know what? I think I'm going to put my glasses on. That's probably the problem here, is that I can't see what I'm doing. So I'll try it again, and I think that's much better. So there we go. That helped.
Yep, there we go.
It always helps when you can see what you're doing. But here's the 2 sensors connected together. And then what we'll need to do as well, obviously, is connect at least one of these sensors to the Pi. And since it's a bus, if we just connect one sensor, we'll actually get the data from more than one. To connect it to the Pi, we use another connector here that has these can see these pins on the end, these header connectors, and that makes it much easier. There's no soldering required, and you may come across some sensors that only have headers on them. That not all sensors have the quick connector. So in that case, you just use something here, these jumpers, or sometimes they're called jumper jerky, and you're going to end up with the same thing. You're going to end up with these jumpers on the other end, whether you use a quick connector to a jumper or you just use jumper to jumper. You want to get these on the other end so that they connect to the Pi.
I think it's also a very good time to mention that we should care about the voltage levels here. So if you're doing it with the Pi, then we need to make sure that the sensors are 3.3 volt compatible, or at least we should use a level shifter.
Yeah, that's true. And most of these sensors all happen to be from Adafruit, and I know that they usually include those level shifters on there, so you don't have to worry about it. But yeah, that is an important note. You want to make sure that they're compatible with the Pi. Some are made mostly for microcontrollers, correct? So those are the ones that you probably want to avoid. But let's quickly connect. What do I have here? This particular sensor is the BMP280, and that is, I believe, temperature and pressure. So we'll see what the air pressure is here. And as far as connecting to the Pi, as I mentioned, this is a 4-conductor bus. So it's power, ground, data, and clock. And on most of the connectors you'll find, they are color-coded wires. So if we hold the Pi like this, and the top of the header, I guess you could say pin 1, is going to be up here, close to the camera connector. Is that camera connector? I believe right there. So the very first pin on the inside is our voltage pin. That's 3.3 volts. So we're going to connect the red one there. Let me see if I can get this in closer so you can see where we are here.
Yep, there
See
we
what,
go.
yep.
In any case, you can refer to the pin diagram from the internet.
Yeah, I mean, definitely refer to the pin diagram, but I'm just quickly go through it here so people can see what they might end up with. The next pin is the SDA. That's the data on the I2C bus, and usually that's a blue wire, so we're going to connect that here. If you're using header to header like this, you'll just have to use your own jumpers, and you'll just have to make sure that you read the values on the pins and make sure they match up. Next one we're going to do is yellow. That's usually clock. And then we're going to skip a pin, and the one after that is ground. And I would do this when the Pi is not powered up, is your best bet to make these connections.
Good point there.
Yep. So this is connected. You'll want to make sure you have some kind of internet access. We can set up Wi-Fi when we flash this SD card. We can set up a Wi-Fi. But for this demo, I'm just going to connect it to Ethernet because it's faster and easier. So I just happen to have an live Ethernet cable right here. So we'll connect that up. And I think we are ready to flash this. And then we'll insert the card and power it up. And basically, at that point, we'll be done. I mean, it will download the application, and it'll just start running. If we're lucky that everything that we haven't forgotten anything, but I believe that
Yeah,
we are in good shape here.
we look good.
Yes, this looks good. It's
So
a straightforward
just
project.
yeah. So just to recap, what Alan did here is connected the sensor to the I2C bus of the Raspberry Pi. And since Alan's doing this all the life, so I would recommend you check the pin diagram before connecting it. If you are not that sure, it's very easy to find the power rails and the STA and SCL lines for the Raspberry Pi. Once that is done, we are connecting to the internet. In this case, we are using the good old Ethernet. But if you are using the Balena dashboard to download the image, you can mention the credentials of the Wi-Fi, and once the device is booted, it will be connected to your Wi-Fi. So did I get it all right?
Yep, that sounds good to me.
Perfect. Let's flash some SD cards now.
Okay, sounds good. So I guess would it be helpful to share my screen
Yep.
for this? Okay, let me do that. So just moving a few things around here. Okay, so I guess most folks are going to start from the deploy with Balena button. Is that correct? So we can do that. It's much easier, I think, to do it that way. If that sounds good, Ian. Just want to make sure I'm still connected here. Okay, well, let's go into GitHub and go to balenaSense. And you're back. That's good.
Yeah.
Ian, so most people are probably going to want to go use deploy with Balena.
Yeah,
Okay.
that's right. So for people who have a bit of idea what deploy with Balena is, so basically with all our common projects, we have this button on our GitHub called deploy with Balena, which once you click, it will take you directly to the Balena dashboard and it will create a fleet for you with that application. So we are using that to save some time here, and it's one of the easiest method to have your fleet up and running.
Exactly. And in order to use this, I think the best experience is to already have created a Balena Cloud account and be logged into it. I think that works really well if
Yep.
you do it that way. Before you hit this button, it'll work if you don't, but you'll have to sign up or sign in if you haven't already. So not to discourage anyone, you certainly can just hit this button,
Yep.
but I think it's easier if you're already. So I'm already logged into my dashboard, and so I believe I already have a project or a fleet called balenaSense. So when I hit this button, it's going to ask me if I want to deploy to an existing fleet. And since that it's asking me this because I already have balenaSense, but I'm going to not deploy it to the fleet that I already have, and I'm going to say create a new fleet, which is what I think most users will see when they get to this point.
Yep.
So let's do it
Absolutely.
that way. It just means that I have to call it something else. balenaSense Hackathon. Oops, Hackathon. balenaSense Hackathon. So what we're doing now is creating the fleet, and then we choose the device type at this point, which will kind of set the tone for our entire fleet. You'll want to choose the architecture of the device here that you're going to deploy. If you're going to deploy multiple devices, this is kind of where you're choosing the architecture. If I choose a Pi 3, I'll only be able to deploy other devices to this fleet that also use the same architecture. And that's not really a concern at this point, but I'm just mentioning it. I mean, it's not a concern if you're just going to deploy one device for this exercise, but I thought I'd mention it here just so you understand
Yep.
why we're choosing a device type. I'm going to choose Pi 3 because the device that I'm using is a Raspberry Pi 3B+. So, and then I believe starter would be the option if you are new to signing up.
That's right.
Yep. Okay. And I think that's it. You can really name it anything that you want, but I think the default will probably say balenaSense in most people's case. So now I'm going to create and deploy my fleet. And when we say fleet, this is kind of like a template for a fleet of devices. A fleet can just be one device, or it could be more. At this point now, I am going to add an actual device. I've created the fleet, which means it's ready to have the devices. It should be, I guess, building the release, or it may have already built it at this point. But let's add a device. So this is where you can add one or more devices to this fleet. A lot of this will be filled out for you already. We'll want the Raspberry Pi 3. We can probably leave the OS as is, and just to note in the background that it is building the balenaSense fleet
Yep.
in the background, which is what we want. We have some options here, development or production. If you're going to tinker with balenaSense and you want to really see how it works, I would use development, gives you easier access. We'll just go for production at this point. But development is great for first-time users, and if you want to tinker with the application, meaning you want to look at the code, or you want to push other if you want to if you want to push other applications to it, or you want to use the local mode, it's written
Yeah,
here.
you want to tinker something up, you want to check what's happening inside, then development is a pretty good way to go ahead.
Yeah, but for our demonstration here, either one will
Yeah,
work fine.
we
And
look
this is the
solid.
point. Yeah, this is the point where you'll want to add in your Wi-Fi credentials if you haven't already. Or if I should say, if you're using Wi-Fi, you'll want to do that here. What's nice about this is that we're going to, if we're going to add our Wi-Fi info here, it's going to be burned into the SD card. So you won't have to go looking for your device, trying to find the IP address or whatever. It will automatically have that Wi-Fi info if we enter it here. And when we burn the SD card, it'll connect right to Wi-Fi and it'll be online, and you'll be able to see it in the dashboard. As I mentioned before, I'm not doing that in this demo because I have the Ethernet cable and I didn't want to take the time to enter these credentials. So let's keep it going. I'm going to download
Yep.
the image for this device. This image includes the OS, and it also is connected to this application. So it's going to download the containers that it needs once we connect it to the internet. And there's a lot of options when you get further into this whole platform. There's many more options about how this happens and what order and different releases, but we're just going through the very basics here. But there's plenty of info
Yeah.
online about all those other options.
So just to recap here, so what we did, we went to the balenaSense GitHub and we clicked the deploy with Balena button. That took us to the Balena dashboard where we added a new device, in this case the Raspberry Pi 3. But if you're having a Raspberry Pi 4, if you're having a Balena Fan, you can choose that. And then we choose if we want a development image or a production image, and if we want to connect to the Wi-Fi, then we can add the Wi-Fi credentials. After doing that, we just downloaded the image, which we are now going to flash to the SD card.
Correct. And this image has everything that the Pi needs to boot up, connect to the internet, download balenaSense, and start running it. So, which is pretty neat. So I'm going to choose the file that I just did, and that was the Balena Cloud, balenaSense Hackathon. It's appropriately named. Didn't even unzip it. If you use Balena Etcher, we should insert the SD card though. Let's do
Yeah.
that. Here you go. So
We are
we'll
still
insert.
not there. We are still not there to flash the SD card without inserting it. So let's insert it.
Yes, well, maybe that technology is on its way, but we still
Yeah.
have to put the SD card in. If I can see the slot here. Yeah, the most difficult part of this process is
Yeah.
finding the slot for the card.
Finding the slots. So once we flash the image on the SD card, the Raspberry Pi will boot and it will show up on the Balena dashboard to
Yep.
download the fleet application which is connected with.
Okay. So since I've used this card before, this is a typical situation where Windows is trying to
Yeah.
load all of the partitions that are on this card. You can just ignore that. You can see it already had plenty. We're going to select that, and we're going to flash it. Okay. And it's a pretty quick process. This should not be a very large image, so this should go pretty quickly. And as you can see,
Yeah, that was quick.
well, it's actually, I guess it hasn't quite burned it yet. It's decompressed it. Now we're flashing.
Okay.
Yeah.
Yeah.
Um,
Still quick.
yeah, it is still quick. And this, like I said, the nice thing is you don't have to unzip it before you use it with Etcher.
Yeah.
So flashing, we're almost there.
Anytime now.
Yep. Flash
There we
complete.
go.
Excellent. Yeah. Okay. So we're going to take the card out and we're going to put it into, I don't know if you have that camera over here. I'm sure everyone's probably familiar with inserting the SD card, but I'm just going to put it in. Okay. I've put the SD card in. Just double check that the sensor is attached, that the pins are correct. And I just did that we have either Wi-Fi, which we set up previously, or we have an Ethernet cable. And then we're going to take our standard micro USB power, plug it in. And you can see that the sensor is getting power off of the I2C bus, so that's a good
Yeah,
sign.
we see some LEDs. LEDs are always a good sign.
Yes. So if we look at the screen share here, we can see that balenaSense has been built and is now kind of part of our fleet here. This is the latest release. You can have multiple releases, but our release now is balenaSense that we built. And as soon as that device finishes booting, it will see that there is a new release available, which is really our first release, our only release, and it will pull that down to the device. If I had multiple devices, it would pull it down to all of them. We could take that same image, that same SD card, and burn it to multiple devices. They would all eventually show up here and pull that balenaSense release down.
Yeah, I see one device. And practically speaking, if I add one device right now in the same fleet, then we can all have the same code. And that's the beauty of fleet management.
Mm-hmm. Exactly. So it's there it is now online. So my device
there we go.
booted up. So I'm going to click on it to see the dashboard for this particular device. And you can see that it is updating, meaning it's pulling balenaSense down to the device. And once it's down there, it will start running it. You can see all the different services or containers that comprise balenaSense 2. And it's downloading them now, and it will start running them, and we should be good to go.
And at this point, if someone wants to add some additional services, like let's say someone wants to add an MQTT broker or some sort of client, then they can also add more to the services and they can push a new release and they can see that everything's happening on the dashboard in real time.
Yes, they could totally do that. All of the code's available for balenaSense, so you could modify it. In that case, what you'd want to do though is instead of using the deploy with Balena button, you would have to clone that repository and then use the Balena CLI after you've modified the code to push the new code to the devices.
We definitely have one talk for that as well for the hackathon. So
good.
Yeah, I think participants would be covered.
Yeah, plus there's plenty of documentation online for that as well.
Absolutely.
So we are doing pretty well with our downloading, and you can see it automatically gave the device a name. You can totally change that if you'd like, but I'm happy with Fragrant Desert, so I'll just leave that alone.
We can also see that on the map where it is at the moment.
Yeah, correct. We could click on location and we only have one
Yep,
device
there we
here.
go.
So let's zoom out in case people aren't really familiar with this area. Now that might make it a little more, yeah,
Yep, that's the
understandable.
device.
So we're on the east coast of the United States.
That's how
So
you can see your devices in the fleet.
yes, exactly. So it's going to go through a few kind of initial startup exercises, and we're going to let it kind of settle down before we actually look at what it's doing. You should be able to pretty much ignore this, but it does need to do a few startup tasks, and that's just the nature of this particular application here of balenaSense, that it does some automated things. So let's see, it looks like it's found what it needs. You may occasionally see something on this application that says, that there's a error in something, but hopefully that shouldn't, it's not necessarily that the application's not working, but let's see what we're getting here. So we could browse to see the dashboard. We could just browse to the local IP address, or we could enable this public device URL, which gives us a public URL that you could give to really anyone in the world, and they could see the same thing.
Yep.
So let's see what we get here. So it's good that we're seeing Grafana.
Yeah, we're seeing
And
something.
and that's what we want to see. And because we used the BMP 280, it automatically found the pressure and the temperature, and it is now plotting them. So this is in millibars, I believe, and then this temperature is in Celsius.
Interesting.
Yeah,
So
yeah.
how often does it update? Like, is it every minute or something?
All of that's configurable. This particular dashboard is preset for 10 seconds. But as far as the sensor itself, I think we'd have to go back into the summary here and see, we can see how often it's pulling the data, but I believe it's about 15, 20 seconds at this point. But if you
Yeah.
look in our repository, there are configuration variables that you can do, and you can enter those right into the to the dashboard itself, and they will take effect. They'll restart the containers. That's in device variable, and you see that we actually already pushed a few in here, and you can change these as needed. All of these are explained in either the blog post or the repository, and I could go in here and add a new variable if the application is aware of that variable. Like the ones that we support, you could totally change how all this works. And the great thing is you're not having to push new code or have to go to the device. This device could be on the other side of the world, and we could just change these device variables and change how this particular application operates.
Right. So it's very easy to configure from the Balena dashboard if you have written your application in such a way that you can modify it depending on the different environment variables. You can change that, and all the changes can be made effect in whatever container you are using. So, for example, for the sensor, you can make change in the sensor container where the value is fetching. For the Grafana, you can make a change in that particular container. So it's really handy to do that without needing to push the code again and again.
Exactly, exactly. And in the case of this particular application, we could theoretically just connect another sensor, daisy chain it onto here, and I would shut down the device first. You can do that here. Shut down the device, attach another sensor. When you start it back up, you should see those additional fields show up here from whatever the new sensor is also providing.
Wow, that's very interesting. Like it automatically knowing what sensor it's connected and fetching the value automatically. That is really mind blowing.
Yeah, it's really neat. And you'll see we really didn't do any coding to do this. We didn't really do any
Yeah.
configuration. And we took a random sensor and connected it. It found the data for it and started graphing it for us. And we didn't, and right on the the root of whatever we looked at here. Like we didn't have to go to any fancy URL. It's just right on the root of the public URL for this. So I could give this particular URL to anybody, and they would be able to access this device if I allowed them to.
Yeah. It's pretty neat actually. to see going from nothing to a working application in no time
Yeah,
and able to push that to multiple devices across the world.
right. And this one also provides the data as MQTT. It has an MQTT broker, so you
Hmm.
could easily pull this data into something else like Home Assistant or, any place that you could process MQTT data. So it's available there as
Wow.
well. So you could use this for many different projects.
That is great. And I really hope that the hackathon participants can make good use of this project since it has everything baked in.
Hmm.
So
Yep.
is there anything else, Alan, you like to tell? Would you like to, show about this project or any very common a thing that people can get stuck into the solution to that? Anything coming on top of your mind?
No, I think we covered, the basics. There's hopefully not a lot to get stuck on here. I mean, it's really a matter of making sure that the sensor is supported. That's important because we don't support every type of I2C sensor. Make sure it's compatible and make sure that it's connected properly to the Pi. And then I think once you have that, it's pretty, I guess you could say, almost plug and play. When you get into here, though, you may want to do a lot more with this. This is just a very basic automatically generated dashboard. In order to modify these dashboards and make something really cool, you would have to sign in so that you can modify them. And just realize that what we're looking at here, everything here is being served up from the device itself. This is all on device. None of this is all local to the device. So what we're doing here is specific to each device and whatever sensor is on there. The default username and password when you get to this point is admin, and then we're going to, you could change it. You should change it. I mean, if you're going to modify it or
Yeah.
use this in any public sense, you'll want to skip that. And now we have the option here to, you'll see you get a little gear icon. And I would encourage people to just play around with this. You can't hurt anything. What you might want to do, though, is save a copy of this. So I go to the gear icon, I hit save as, and I'm going to call this copy. You could call it whatever you want. Now I'm working with a copy. So you really have no excuse for not going in here and just playing around and seeing what you could do with this. I'm going to, let's see, I'm just going to quickly edit this and I'm going to change the visualization, to a gauge. And now I've got something cool here. I've got a pressure
Wow.
gauge.
Yeah. A very big playground to play with.
Yes, there's a lot you can do with this, and all of your sensor data will be available here. So you could do this in multiple ways, mix and match. So I would recommend having fun with that. Just remember to save any changes that you make because otherwise you'll lose them.
Yeah, and having said that, we'll share the list of supported sensor during the hackathon. But it's all open source, and you are welcome to add support for new sensors. PRs are always welcome.
Absolutely.
Awesome. So I think that was a really cool demo, Alan. Thank you very much for doing this, and I am really looking forward to people using it and coming up with all kind of projects. So yeah, thanks a lot for doing this, and uh, I'll definitely bring you questions if people have. But
Sure.
there will be more balena stars in the during the hackathon helping you around with everything. So if you have any question, if you want to share any idea, discuss it, feel free to do that. All right, Alan. Thank you so much for doing this. I think Anuj has already slept, but Anuj, if you can hear us, thanks a lot for being here. And yeah, catch you again soon.
Bye
Bye
bye.
bye. Okay, Anuj.